thing I want to go through is when you do worksheet 6-4, you're going to cross off number 5 and you're going to cross off number 11. We're crossing off number 5 because I talked about how to do this with money. I didn't talk about it as a mixture. I said you could do it as a mixture, but I didn't do that problem as a mixture. So I'm going to cross that one off. And then I'm crossing off number 11. I just feel like it's a little bit more complicated and not maybe necessary for us. These are the ones we started yesterday. We started those ones yesterday, so you have those on a separate sheet already. We also don't need to explain, so you can cross off where it says explain the method you used. What that means, by the way, would be like to say, oh, I used substitution because a variable is already isolated or something like that. What I'd like to do is just kind of run through a few simple things with you. I'm going to talk a little bit about number 1 and talk a little bit about number 2, and then I'm going to set you off to do the rest. I want you to look at number 3, though. Number 3 is a break-even problem, so I want you to write that down. It's like the very first problem I did with you yesterday in the notes. Yes, Jean?
So like first one would it be easier to be like an actual definition or not?
Say that one more time. I can't quite hear you.
Because it's easiest, would that be like an acceptable explanation?
It wouldn't, but you don't need to. But when I made my advanced kids explain, and they had to give me a really clear definition or explanation. So they had to say, because this variable is easiest to isolate. And then they had to say, because the coefficients are multiple, or least like in the same number family or something like that. They had to say things like that. And if they didn't explain it that carefully, then I would take the half point off for not explaining. Number 6 right here, I'm going to go through question number 1 with you, and number 6 will be like number 1. So I want you to write that down, which I'm going to go through and help you set up in a minute. And it's also going to be like ones from words, Mrs. Twyfok. It's going to be like problems from worksheet 6-3. We would have seen a few from worksheet 6-3. You would have recognized them from there. I missed one somewhere. Oh, number 4 is a geometry problem. It was the last one we did yesterday. Number 4 is a geometry one, and it was the last one we did yesterday. Obviously, it would be the one where we drew a little rectangle. And and then this last one, number 12, it is also a break-even problem. So you'll want to check your notes. Again, that's the first problem I did yesterday where we talked about the play or the musical. All right, so let me help you get number 1 and number 2 sort of started. You probably already have a few of these done. Like I said, you had numbers 7 through 10. Some of you have them already done. Some of you just have a few of them done. I understand if your assignment's a little bit out of order then when you start doing it. So number 1 we have here, it says the concession stand is selling hot dogs and hamburgers during a game. At halftime, they sold a total of 78 hot dogs and hamburgers. And they brought in $105. That sounds like another total. How many of each item did they sell if hamburgers sold for $1.50 and hot dogs sold for $1.25? Notice how I used 2 different colors here as I was underlining. Part of the reason for that is I'm thinking of the categories that I'm hearing. I'm hearing there was a number of items, and then I was hearing the cost of those items. And when we were doing 6-3, that was kind of what we were doing, is we were categorizing by here's a number of and here's a cost of. So you can use 2 different variables. Since these both start with H, you might call this like hot dogs and this hamburgers, like that. That might make it easier to kind of differentiate the 2 or keep them separate. So if you combine them, the combined total of them, there are 78 that were sold together. So you would say for number 1, the hot dogs and the hamburgers totaled 78. And remember, when the total is a number and not a variable, you have a standard form equation. When they say to you the total is 42, you have standard form. When they say for the total number of, and it's more of a varying amount, then you have mx plus b. The next thing that they total for you here is this 105.50. So you'd say I have a 105.50, but it tells you that the burgers are $1.50. So I'd say the burgers are $1.50. And it says that the hot dogs are $1.25. And then it's $1.25 for the hot dogs, like that. Watch the order when you put things in, especially when you're working with standard form, because you may want to be doing your standard form as elimination. So remember, you have your different options for solving. When you go to solve, remember our notes from yesterday. When you go to solve, you can isolate a variable and then plug it into the other equation. Or you can stack those two equations up and look for that pair of opposites or same and add them or subtract them. That's up to you. I don't ever really talk about graphing because it's kind of a bummer. Most people wouldn't do it. And you oftentimes have to estimate where they cross, and you wouldn't want to do that either. You'd want a specific answer, a very accurate answer. So it's up to you then here. Do you want to isolate D and plug that in? Or do you want to take this times something and then put it underneath there? What would you guys most like to do? Do you like elimination or substitution? Okay, so when I do elimination on one like this, I actually multiply both of the equations because I don't like the decimals in there. That's just me. Yeah, so I multiply by 100. Yeah.
Would you always put the money together in this kind of problem?
I tend to. There might be some situations where I don't, but I almost always do. There might be a situation where you're trying to gather up different things. So there's problems where it says you buy 2 sweatpants and 3 shirts and it costs $50. You buy 8 shirts and 2 sweatpants and it costs $70. Then there's money on both of those problems because those were total amounts. So there's times when money sits in both equations though. But yeah, usually when it sounds like this, it's like a total number of and a total cost. All right, so I'll take this one times 100. And that'll get me 125 and 150. Oh, drat. There we go. All right, now this one, I need to create that set of opposites, remember? So I can multiply this equation by 150. I can multiply this equation by 125. I just need to create that set of opposites. I might go negative 150. So then this would be negative 150. Like that. And then that's going to have me eliminating hamburgers right there. And if I add, I'm adding because I have opposites right here, or right here. So I have 125 and negative 150. That gives me negative 25D. And I'm just moving that closer to the equal sign. And then I've got this negative 11,700 right here. And I'm just going to add 10,550 to that. And I get negative 1,150. And sometimes when you're doing a problem like this and you think, I just added these two. When you're doing a problem like this and you think, man, I'm not supposed to have negatives. But remember, you're about to divide by a negative and that will make it no longer. negative at all. So I'll divide by negative 25. Remember, your negative sign is down underneath the 3. And you get 46. So that's 46 hot dogs. And then you just need to take that 46 and plug that back in over here and find out how many hamburgers you have. And I'll pause right now while you do that. Yeah.
Would you keep the multiply by negative 150?
Yeah, I would not while I do this.
Okay.
So that's sitting there. I'm plugging this in right here to the like the way it looks right there. And then you finish that out. And then when you have your answer, you don't need to write it like a point. Just leave it as here's how many hot dogs I had. And then you'll have your answer here for how many burgers I had and label that. Number 2, I wanted to just look at with you because we've done problems like this, but it looks a little bit different. Yeah, Jean.
For number 2, do we need to have an equation?
Yes, there'll be 2 equations for number 2. And I feel like the language of it is what's throwing people off when they see it. There's one that makes sense, or at least sounds a little bit like what you've seen. The first one. It says the sum of 2 numbers is 67. Do we know what the 2 numbers are?
No.
So we can just say x and y equals 67, right? Now, if you prefer to do substitution, you can take this next sentence exactly the way it's worded. It says that the smaller number is 3 less than the larger number. And of these 2, you have no idea which one is the smaller and which one is the larger. And it really doesn't matter. You get to be the boss of this problem right now. You're the one setting it up. So you could just come out and say, well, since I'm deciding, I'm going to say that, I don't know, y is the smaller number. So y is, and how do you say something is 3 less? Negative 3. So you would have to say, where is a pen that people will see? There we go. Y is 3 less than x. You could write that equation like that. Let's say you don't really like substitution, though. You would prefer to do elimination like this. If this is true, you could also say instead, if that's not your jam, you could say if x and y, if y is 3 less than x or x is 3 less than y, depending on how you write it, it's true that the difference between x and y is 3. You could also write it like that if you wanted. One's bigger than the other. The space between them is 3. You could also write that if you would prefer to do elimination. It's up to you. You do your thing. I had one like this in our notes yesterday that I wanted to do so we could practice it, but I just didn't get to it. I felt like notes were getting a little too long yesterday. That's it for me going through problems with you. I want you to just work on your own now. And then remember, you need your notes out because you need to be reminded that there are 2 types of equations for a break-even. There's a geometry one, and then this one's going to look just like number 1 that I just set up with you. And then there's another break-even. Now, if I give you an assignment with 2 break-even ones, you can be assured there'll be one on your quiz on Friday, right? Mm-hmm. Probably makes sense. So please make sure you know how to do that one. Yep.
When you're doing like elimination,
yeah,
wouldn't the x negative y equal negative 3?
This one here?
No, the one, yeah.
Oh, because when you say that one number is 3 less than the other, then you're saying that the space between them is 3. It doesn't, when you put this as negative, that's the one that is less. Like that one number is smaller than the other. So I put the negative sign in there. I just put it with the variable instead of the number. Kind of a weird way to look at it, but you could do it that way if you want. This might be more logical though. Like this is a far more logical way of looking at it. All right. Go ahead and listen to music if you like. I'll mill around and just answer questions. Make sure you have your notes out so that when I'm helping you, we have something to look at and talk about. I don't want to just give answers. That's not cool.
Can I have a sheet?
Yeah, they're on the table.
Oh, all right. Thank you.